Mars. Now that mission's not going to happen until about 2030, 2035 sometime, so we still got a good another 20 years before that gets underway. Now the reason that we're waiting so long is because of the distance that we have to travel, and also the amount of obstacles that that poses for us. The moon was located 3 days away, 240,000 miles in distance. Mars is 6 months away, 35 million miles at the closest that it ever is to the Earth. So you're talking about 6 months just to get there, 6 months to get back. And then on planet, we could stay for as long as a year. If we stay for longer than 45 days, then we have to stay for a year, because there's only a 45-day window where Mars and Earth are aligned in their orbits where we can make that 6-month journey. Longer than 45 days and they're no longer lined up, so it'll take you longer than 6 months to get back. And we're not going to attempt a journey for that long. So if we stay for longer than 45 days, we're going to wait 1 full year for Mars and Earth to realign, then make that 6-month journey again. So we could be looking at upwards of a 2-year-long space mission, ladies and gentlemen. And I'm talking about 4 astronauts, 4 human beings spending 2 years in a spacecraft that's going to be no larger than driving around a van down here on Earth, ladies and gentlemen. So how are these people going to survive? How are they going to live, eat, sleep, use the restroom, change their clothes? The food supply itself. Are we going to grow food on this spacecraft, or are we going to pack an abundant supply of food to make sure that everybody has enough to eat? Those are the challenges and the obstacles that we're trying to overcome and deal with right here and right now. That's why it's taking us so long to get this new space program underway. Also, the microgravity environment presents a unique challenge because when you go up into space, your body is going to start to change. We don't really think about it down here on Earth because we're so used to it and accustomed to it, but we have 1 G of gravity that is pushing against us at all times. Even right now as I'm speaking to you, we have 1 G of gravity on us, holding us to the surface of the Earth, also holding our bodies together as well. So when you go into space and this gravity is no longer there, your body is going to start to change. Your muscles and your bones are actually going to start to deteriorate, start to shrink. It's called atrophy. Your bones will get smaller and they will start to get further apart as well. I mentioned how gravity is holding our bodies together. Well, when we don't have that gravity that's holding us together, it gives your bones a little more freedom to move around because nothing's keeping them in one set location. And they do that. They move around when you're up in space. So to keep our astronauts in working condition, I forgot to mention the muscles as well. Muscles deteriorate. They do down here on Earth, but it happens at a much faster rate up in space. If you stop working out down here on Earth, you're going to get weak eventually. But in space, it happens very, very quickly. If you spend 6 months on the station and don't do anything, no exercise, just eat whatever you want to, watch TV the whole time, then when you get back to Earth, you're not even going to be able to stand under your own weight. Your bones may not even support your body. That's how deteriorated that you get. So to keep this from happening, we have our astronauts perform 2 hours of physical exercise per day. 7 days a week, no matter what, they have to perform 2 hours of exercise just to keep them in a working condition, keep them safe enough to return back here to Earth. And for a 2-year-long mission, we're going to need to develop some new technologies, some new procedures to stop that from happening even more so than just 2 hours of physical exercise does. Maybe some medicine that you can take, something you can inject into your muscles to stop it from happening, different things like that. So that's what we're working on right here and right now, trying to make this mission safe and successful for the astronauts before we ever attempt it. Now, in between now and 2035, while we're waiting on the Mars missions, we're also talking about trying to land on an asteroid. Mine samples from the asteroid, study those materials, bring them back here to Earth and study them. We may be able to find out more about our solar system than we ever have before because we've never been able to travel as far as the asteroids have. They may have some materials and things that we've never seen before because we've never been able to get out there. Also, we're talking about maybe trying to stop an asteroid and deflect it away from the surface of the Earth. We had a scare in Russia a couple months ago where they had an asteroid enter the atmosphere and explode just over Russia, and it did damage down on the surface of the Earth. The actual explosion caused windows to shatter down here, different things like that. No kind of human damage was done, thank goodness for that, but it was a real scare that we had. And so we're trying to take steps and precautions to block those away, deflect them from ever entering the atmosphere so we don't have to worry about that. Keep life safe for us down here on Earth. It's kind of like the science fiction movie Armageddon, if anyone's seen that before. A huge asteroid's coming towards Earth, and it's so large, if it hits, it's going to destroy all life on Earth. We sent a team up there, they exploded it, and diverted it away from Earth, saved everybody's lives. Not expecting anything like that to happen, not a catastrophic event like that. If anything like that was going to happen, we would see it coming, a long time in advance. But we're starting to take steps, precautions, get contingency plans set up just in case something like that were to happen in the future. Start out small and get bigger and bigger and bigger as we move up in technology and advancements, different things like that. Basically, what I'm trying to let you guys know here today is the space program is not going anywhere. We're going to be here for many more years to come, and we're looking forward to a lot more exciting things here in the future at NASA. And ladies and gentlemen, what you are looking at here today, this is the future, the Orion Mission Control. Now, unfortunately, ladies and gentlemen, that's all the time that we have for this building here today. Does anybody have any questions about our space program, past, present, or future? Just raise your hand up in the air. I'll be more than happy to try and answer any questions. Anybody got anything? Yes, sir. Hang on, right behind you, quick.
By the way, the asteroid mission could be very dangerous.
You're right, it could be.
It could crash into a planet and explode.
You're right, very good. There's high speeds. They're traveling at 25,000 miles an hour. Trying to land on something going that fast is going to be real dangerous. Yes, sir. On the upper right-hand TV screen right over here, ladies and gentlemen, that's the International Space Station control room. It's manned 24/7, 365. Always someone on the station, so we always have to have people inside that room. That's a live shot as well, so the people you see sitting right there are actually communicating and keeping up with the space station. The attitude, the altitude, the lights, the heating, all that stuff is controlled from that room right there, and it's a little bit down the hallway from where you're sitting right now, in the same building that we're in. And it's actually, we've had a long-running record here at NASA. We've had an American astronaut in space 24/7, 365 for the past 12 years running, all the way through. So that's a record that's still going on as I'm speaking to you right now, happening on the space station. Anybody else have anything? Yes, ma'am.
What's the average age of the astronaut you think will go to Mars?
Average age of the astronauts going to Mars will probably be mid-30s. Usually that's about what our astronauts, when they go into space, different things like that. Usually you don't find young astronauts in their 20s, different things. Late 20s maybe, but usually early 30s, that's around the time.
So our elementary kids.
Yes, exactly. All right, ladies and gentlemen, well, unfortunately, that's all the time we have for this building today. If you have any more questions, I'll be standing at the top of the stairs. When you get back downstairs, take the same seats you had as last time. Other than that, thanks for your time and attention, guys. Enjoy the rest of your day.